Good afternoon, everyone. We are halfway through the week, and we've got some stuff to do. First of all, I want to mention I know you guys had some sound trouble yesterday with the video, and I don't know what it is because when I play it back on my computer on YouTube, it's the same. So I don't know if it's the volume settings on the computer, on YouTube, or on the speakers. I don't know what's going on. I'm trying to speak louder in this, so I hope that helps. You guys can check those settings. A few of you have emailed me about getting the links. Please do so if that helps. It might work better on your computer. And another thing, I know I'm talking kind of fast and I'm going through these kind of fast, and that's because I only have 15 minutes of recording time. I don't know why that is, but for whatever reason, after 15 minutes, it just stops and it won't do anything. So if you guys need to see this again, if you want me to send it to you again where you can pause, where you can rewind and do whatever, please, please, please email me. It's not a big deal. Use these to your advantage. This is the best I can do with what I have right now. So, and another thing, on yesterday's worksheet, the motion problems one, I told you to ignore number 1. Only ignore number 1A. You guys can do the rest of it according to the lecture yesterday. If you need to see that video again, have Ms. Hernandez play it again for you, and hopefully the volume will be better today. But today we're going to continue on a little bit. Yesterday we were talking about horizontal motion, and I said today we would talk about vertical motion. So we'll talk about a little bit of that today. It's not too new, it's just a few new things. So let's talk about free fall. So what is free fall? Free fall is basically when you drop an object, right? So when you drop that object, there's no forces being acted upon it other than gravity. So it's not, being pushed back and forth or anything. It's just going straight down. In this class, we're going to neglect air resistance, or what we call air friction. Now, that does exist, but for this class, we're not going to talk about it. That's for future courses. So I know that's not very realistic, but you need to know this in order to move on and then add air resistance later. So the force of gravity and the acceleration due to gravity, this is what we call g. And it's how much an object near the surface of the Earth accelerates towards the center of the Earth. And on Earth, this acceleration is 9.8 meters per second squared towards the Earth, or for us, it'll always be down. Again, acceleration is a vector, so it needs a direction. Like I said, on Earth, it's 9.8 meters per second squared. On the Moon, it could be something different. There's gravity everywhere. Please remember that. So right now, we're only going to be talking about earthly things and free fall on Earth. So basically, if you drop anything, it's going to accelerate towards the center of the Earth at 9.8 meters per second. And it doesn't matter how big or how heavy or how small or anything. This is a constant. It's been tested over and over again, and it was first brought out by Galileo. So I will show you a couple of videos of what I'm talking about. The first one's going to be a feather and a ball bearing. They're going to be dropped. So let's get started. So here it's at atmospheric pressure, which means, it's in the air. They're dropped at the same time, and obviously the feather takes some time. That's because of air resistance. So now all the air is being removed, and we're in a vacuum. They're going to drop it at the same time, and as you can see, they fell at the same rate. So it doesn't matter how big or how heavy it is. So here's another video demonstrating this on the Moon. They're going to drop a hammer and a feather. So take a look at it and observe. So there you have it. Doesn't matter what size or how heavy, it's going to fall down at the same rate no matter what you are. So let's do an example. of free fall. So again, this is just like the horizontal motion, but we're going to do it in vertical. So the first example is how far will a brick starting from rest fall freely in 3.0 seconds? And we're going to neglect air resistance. Now this seems like a pretty simple question, or at least it's short, and it is. So what are we going to start out with? We're going to start out with our list, right? We always start out with our list. Now what we haven't been doing before is we haven't been picking a coordinate system, and this is just to show where you want the positive direction to be. Now, since you're picking it, you can have it be anywhere that you want, but you have to be consistent throughout the whole problem. So I prefer my positive direction to be up. Sometimes it'll be easier to be down, but in this case, I'm just used to having a positive direction be up, so my positive direction is up. So here's my list. Another thing is that I did put Y instead of X here, and this is because we are in the vertical direction, just to be consistent. Again, X is horizontal, Y is vertical. And this is going to be more important when we start getting into two-dimensional motion and projectile motion. So try to get into the habit of, if you're doing vertical problems, you use Y, and horizontal problems, you use X. So now we're writing down everything we know. Since we chose our coordinate system, positive is up, and my original, my starting point is 0. This is what I chose to do. I mean, I could have had, it be 50 or negative 20. But for, simplicity's sake, I chose my starting point to be 0. This is what we're looking for. We're looking for how far it goes in 3 seconds. Now, our original velocity, it starts from rest. So our initial velocity of 0, and we don't know what our final velocity is, but we know our acceleration, right, because it's free fall. Since we picked a direction of up, and acceleration is always towards the center of the Earth, acceleration is negative in this case, and our time is 3.0 seconds. So this is what we have, this is what we want to know, and these here are our tools. So looking at these tools, what equation do we need to find YF? And it happens to be this one right here, what we call the big equation. So just simply plugging in 0 plus 0 plus 1/2 AT squared, right? So we get a negative number. Can we get a negative number? Sure, because we started out at 0 and we said our positive direction is up. So our final number is negative 44.1 meters. Or you can say 44.1 meters down. So in 3 seconds, the brick falling from rest is going to go 44.1 meters. Obviously, it's going to go down. When you let go of something, it's not just going to float up into the air. So now let's talk about objects that are launched upwards, something that you throw up. You have a coin in your hand and you're throwing it up, you're flipping a coin, whatever. So in order for something to go up, it has to have an initial velocity. If it starts at 0, something has to make it go up. At the highest point, the object's going to have a velocity of 0. And this is only for an instance. And it has to have a velocity of 0 because it's going to come back down. It can't just constantly be moving and then not have it. But again, remember, this is only a velocity of 0 in the vertical direction. When we get into 2D motion, it's still going to have a horizontal velocity, but not a vertical velocity. So at the highest point, you're going to have a velocity of 0. And this is true for all things that just go up and then come right back down. The acceleration is constant, again, and this is at all times. Acceleration does not stop at the top. Even though you have 0 velocity, if you had 0 acceleration, you'd throw it up and then it would just stay there. That'd be really awful if you tried to throw anything up. I can think of a lot of funny scenarios of what you could do with that, but that's just not how it works. Acceleration is constant, 9.8 meters per second, all the time, no matter what the velocity is. So, also what we can do with this, a little trick, is that there's going to be a symmetry of motion. So what happens on the way up is going to happen on the way down. That's going to be mirrored. So a lot of these problems, what we can do is that we can break them down into 2 pieces, and sometimes we only have to solve half. So let's work on another example problem. Erin plays basketball. So she jumps straight up to grab a rebound, and she's in the air for 0.8 seconds. How high did she jump? again, what we're going to start out is with our list, and we're going to write down everything that we know. Since we set the coordinate system, again, I set the direction of up to be positive, and I set my starting point at 0, 0, wherever Erin started. So we have her initial position at 0. We're looking for how high, right? Her initial velocity, we don't know, but we know at the top she's going to reach 0, right? Because at one point she's going to have to turn around and come back down. She can't just stay floating up there. And again, your acceleration is negative 9.8 meters per second squared. Always, 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 right? And it's negative because we chose our positive direction to be up. Our acceleration is always going to be down. So depending on how you choose your coordinate system is going to tell you whether your acceleration is negative or positive. Now our time here, you see that I put 0.4 seconds, even though up here it says 0.8 seconds. Like I said, there's a symmetry of motion, so the way up is the same as the way down. And we only have to solve half of this problem to find how high she jumps. So halfway up is 0.4 seconds, or I'm sorry, halfway is all the way up, which is 0.4 seconds, and then on the way down is going to be another 0.4 seconds. So we're only solving half the problem, and so our time is going to be 0.4 seconds. Now let's look at our tools here. None of these actually are going to help us solve the problem directly, because all of them have your initial velocity, which is something that we don't have. So we're going to have to do another step to find out how high Erin jumps. So we're going to choose the little equation right here to find our VI. So we just rearrange to find our initial velocity, and then we just start plugging because we have everything else. We have our final velocity is 0 minus a negative 9.8 meters per second squared times the time. So a minus a negative is going to be a positive, which makes sense. So her initial velocity is 3.92 meters per second up, right? It's positive. We chose our positive direction to be up, so our direction is up. So now we have this new piece of information. Now our other tools, now we have 1, 2, 3, 4, 5. We have 5 out of 6. So that means we can use either of the equations that are left to find her final position or how high she jumps. You can choose either one. A good way to check your work is to choose one and then do it with the other and see if they match. I chose the squared one because we haven't used that one yet. So here's our original equation right here. Right, here's our original equation. And so I just rearranged it to find your final position right here. So our final position minus our initial position. Oops, there you go. See, I forgot to change the y there, so be careful. But anyways, so we have our initial velocity, or our final velocity to be 0 minus the initial velocity, which we found in the earlier equation, divided by 2a, that negative 9.8. So a negative divided by a negative, we get a positive number, which makes sense because our positive direction is up. And if Erin was to jump and to go down, there would be problems. So let's look at this number. Now we have this number, and I'm not too concerned sometimes about numbers. Sometimes you'll get a number and you think it's right, but I want you to think about, is this a reasonable number? Can Erin jump 0.78 meters? Now a meter is about a yard, give or take. So is it possible for someone to jump that high? Yeah, that's pretty reasonable. That's a good jump. I personally can't do it, but it's very possible. So this is kind of how to do the free fall problems. You're still using your kinematic equations, so all you know now is that if you're throwing something up, your final velocity at the top is always going to be 0, and your acceleration is always 9.8 meters per second squared towards the Earth, or for us it will be down. So I hope this helps. I hope you guys could hear me. Please, please, please email me if you have questions, if you want the link to this. You're going to get another worksheet now to work on, so work on it. The solutions are available. Try it out. Tomorrow will be a work day, so if you want to watch these videos again, or if you want to work on these problems, please do so. We'll do something light on Friday, and I will see you guys on Monday. I cannot wait to see you guys. So I hope you're doing well. Take care and good luck.